Good morning, everyone. Welcome to the STEM Lockdown Digital School. This is Grade 8 Natural Sciences. I am your presenter, Onkarabetse Setso, and you guys can get hold of me on Twitter at onkarabetse_s. Right, so guys, today we're just going to continue from where we left off yesterday, but we're just going to start with just a quick recap. So yesterday we looked at expansion and contraction of particles, right? And we said that expansion refers to the process of taking up more space, and contraction refers to the process of particles taking up less space. And we also mentioned that during expansion and contraction, the mass of our substance stays the same. So we also looked and said that matter doesn't always change state when temperature is added. Some materials slightly expand when they are heated, and some materials can also shrink when they are cooled. All right, so remember we looked at the example of the joint ridges that are put on the bridges when bridges are built. All right. Then we had technical issues while we were dealing with this question here. And I asked you guys a question, the last question that we had rather, when we were looking at this example. And my question was, which material would be best to reinforce concrete? And I would like you guys to actually give me an answer to that question in the group chat. All right. And then please also take screenshots. Please do take screenshots for today's homework. We will mark the homework in tomorrow's lesson. Right. So can I get an answer, guys, as to which material would be best to reinforce concrete? Remember, we did say that reinforcement means when you strengthen something or you are supporting something. All right, I see Favor Gift says iron. Tanisha says steel. Zamagusha says iron. All right. Natalie says iron. Okay, so guys, I would also like you to basically motivate your answer. Why do you guys say iron? And those who say steel, why do you say steel? Because I see there's like a tug of war between iron and steel. Why do you say iron and why do you say steel would be the best material to use when we reinforce concrete? Remember, concrete expands with 11 millimeters. Steel expands with 11 millimeters. Iron is 12 millimeters. That is when temperature is increased or this material is heated. Please, guys, motivate your answer. Why do you say iron and why do you say steel? Okay, Tanisha says, because contractors use steel rods when reinforcing concrete. And Favor Gift, so I believe you said steel, Tanisha. Then Favor Gift says because iron is strong and can be put together with concrete. All right, guys. So I need your motivation, right, to be in terms of what we have learned so far. What we have learned with regards to expansion and what we have learned with regards to contraction. Okay. So supplement your answer in terms of what you have learned as to what the particles do in those type of materials, right? So Tanisha says it is steel because contractors use steel rods when reinforcing concrete. Then Favor Gift says because iron is strong and can be put together with concrete. All right, so your answers are quite similar, but I need a differentiating factor between your answers, guys. Why do you say steel or iron can reinforce concrete? And remember, guys, the question was which material would be best to reinforce concrete? And I saw a tug of war between iron and steel. And I want you guys basically to motivate your answers. Why do you say iron and why do you say steel? Oh, guys, you are awkwardly quiet. I'll give you guys a few seconds and then we can just get into the answer. All right, favorite gift, no problem. That is just being honest. All right. So guys, remember, when we say we are reinforcing something, we are supporting it and as well as strengthening it. So if we were to choose a material to support concrete or to reinforce concrete, we need to choose material that would expand in the same way that concrete would expand. All right. So concrete expands with 11 millimeters and steel expands with 11 millimeters and iron is with 12 millimeters. So the closest one that expands like the same as the concrete would be steel. All right. So yes, steel is the best material to use when we are reinforcing concrete. Not to say that other contractors don't use iron, they do, but the best material to use when reinforcing concrete is steel. All right. So I hope everyone is following and you understand why steel is the correct answer. And guys, just another thing here, we wouldn't use ordinary glass because it would break. Okay, in as much as it has the same expansion length as steel, it is not good for concrete because it is not strong. All right, it's brittle. Okay. Hope everyone is following. So guys, remember, please take a screenshot, okay, of these values. And I need you guys to draw a bar graph with expansion on the y-axis and materials as categories on the x-axis. Okay. You need to choose an appropriate title for your graph. Okay, and that is your homework for today. All right. Just indicate to me when you're done so we can move on to the next slide. Right, you guys can just press the yes on participants if you're done so that we can move on. Lala, I think your video is on. I'm not sure if you can realize it. Okay, beautiful. Okay, so guys, during today's lesson, you should be able to explain how gases respond to pressure. So today we'll be looking at pressure, but with regards to gases or particles of gases. All right, so you need to be able to explain how gases respond to pressure. You need to be able to describe ways to increase the pressure in gases. Okay. So guys, pressure. If just a question for you guys, how would you define pressure with regards to gases? How would you define pressure with regards to particles of gases? Just need an answer or two, then we will get into the details of pressure. How would you define pressure in terms of particles of gases? Okay, favorite gift says adding more. So I believe you're adding more of the gas and you're increasing the pressure. All right. Anyone else? Anyone else with a different answer? Okay. All right. So favorite gift, you are on the correct track. So guys, pressure, it can be defined as the force that gas particles exert on the walls of the container in which they are in. So first point, guys, gases can be compressed. Okay, so that is one of the characteristics of gases, that it can be compressed. So yes, Helen, something like compressed, yes, gases can be compressed. And then second point is that there is ample space between particles, right? So remember, if we look back at the particle model of gases, there's huge spaces between the particles, and hence we can compress them. Right, then liquids and solids cannot be compressed because there isn't enough space between the particles for compression to take place. All right, so now pressure from bumping particles. Pressure is an important property of gases. Particles are in constant fast movement. Remember, we're dealing with gases, all right? So when particles hit the side of a container, we say that they are exerting pressure, okay? But when particles bump into each other in the container, we're saying that they are colliding, or a collision is happening. Okay, so then we have on this slide, Samaguhle. This one. All right, cool. Just give you a few minutes. Just indicate to me if you are done. Then I can just also read it out. We said that gases can be compressed. There is ample space between particles. Then liquids and solids can't be compressed because there isn't enough space between the particles for compression to take place. All right. So Zamagusha, just indicate to us if we can move on. All right. So do you also need to write down information from this slide, Zama? Or can we move on? Done. All right, perfect. Okay, so then we have two ways in which we can increase pressure of a gas. So just like Favor Gift said, that we can add more. So firstly, we can pump more gas into the container. And secondly, we can make the volume of the container smaller. Okay, so remember yesterday when we looked at expansion and contraction, and we were moving particles from a smaller beaker into a larger beaker, and we said that we can also do that vice versa. And when we move particles from a larger beaker to a smaller beaker, we are increasing the pressure. All right. Okay, so now when we use pumps or gouges, so the pumps are used to put in more gas into a container. Then we use a pressure gauge to measure the pressure of gas in a particular container. For example, where pressure gauges are used and pressure pumps are used is when in fuel stations, right? When they put in pressure of the tire, you can measure the pressure that's in the tire, and you can also measure, or rather, you can put in more gas in your car tire. All right. So here we have an example of a tire pressure gauge. And another example of a pump is the pump that is used to pump balls, soccer balls, rugby balls, netball balls, etc. All right. So guys, let us look at the effect of heating and cooling on pressure of a gas. So guys, I'd like to ask, what do you think would happen to pressure of a gas when that gas is heated? What do you think would happen to the pressure of a gas if the gas is heated? What would happen to the pressure of the gas if the gas is heated? It will blow up. Okay. Won't it explode? All right. It could increase. Great. All right. So I see most of you guys say that it will blow up, it would increase, it won't it explode? That's Nhlanhla asking me a question. All right. So now let us look what would happen to particles of a gas, or rather to the pressure of the particles of a gas when it is heated. So guys, if a gas is heated, the particles will move faster. All right. So remember, when you are giving answers, refer to the particles of gas, refer to the physical properties that we have been looking at. All right. So firstly, the particles will move faster. This is before the explosion or the blow up that might take place. All right. So the gas particles will move faster because they have gained more energy. Then we have more collisions that would take place and would have an increase in pressure. And if heat is increased, that is when we'll have our blow up or our explosion. All right. So a typical example would be blowing up a balloon, right? Indoors, like today is very cold, blowing up a balloon in your room, and then you move outside. So the sun is out, guys. If you move outside, the temperature in your room versus the temperature outside is hotter. Okay, so then you would heat basically your balloon if you move from your room to a the sunny field or on your grass or wherever. Okay, but your balloon won't immediately blow up. All right. So that is why we do not jump to the conclusion to say that when we heat a gas, it blows up. All right. We say that particles will move faster because particles would have gained more energy and more collisions are happening, and we have an increase in pressure. All right. So I hope everyone is following. Okay. So here we have particles in a hot gas. So here we have more and more energetic collisions that are taking place. All right. Then if we were to cool the gas, what happens to the pressure? So now if a gas is cooled, the particles will move more slowly because they have less energy. Therefore, we'll have lesser collisions happening in the container, and gas pressure will decrease. Again, we can take the example of the balloon. If we move from a higher temperature to a much lower temperature, for example, as we said, moving from outside of the house into your room, okay, so it would mean that we are cooling our balloon. We'd have lesser collisions happening in the balloon, and the balloon is less likely to explode in your room than it is outside. Okay, so I hope everyone understands that. Remember, do not jump immediately to the blowing up conclusion. Okay, explain what happens to the particles. All right, is everyone following? Okay. All right. Beautiful. Okay, so here we have also a picture that is indicating to us the particles of a cool gas. We said that we have fewer and less energetic collisions happening. Okay, remember, collisions are when the particles are bumping against each other. All right. So guys, remember, if you do have any questions, do send them to the group chat, because I have 1, 2, 3, 4 students who said they are following, and I don't know what about the others. I don't know if the others are also following or they're still a bit confused, right? So if you do have any questions, just write them in the group chat. Okay, next slide. How does changing the volume of the gas affect pressure? And that's a question for you guys. How does changing the volume of gas, affect pressure? How does changing the volume of gas affect pressure? And you guys can even just, to answer this question, refer to what we learned in yesterday's lesson with regards to expansion and contraction. How does changing the volume of gas affect the pressure? Remember, guys, you can alternatively raise your hand if you want to answer, or you can write in the group chat. Okay, so Nhlanhla says it decreases and does not expand. So if we change the volume of our gas, it would decrease and would not expand. Right, then Mike says less space for gas particles to move around. And I'm assuming that is when we are reducing the volume. Then Chesa says when volume increases, we have less collision and less pressure. Thank you for that beautiful answer, Chesa. Helen says the smaller the volume, the bigger the pressure. Beautiful, Helen. And then the bigger the volume, the lesser the pressure. Thank you, Helen. And that is correct, guys. So when a gas is squashed in a smaller volume, particles have less space to move around. And then we have more collisions that will take place. And we also have an increase in pressure. All right. So remember, the opposite is also the same. If we have a bigger volume, right, we'll have more the particles will have more space to move around and will have less collisions and a decrease in pressure. All right. So here we have an example that is basically depicting what we have just said. Here we have a greater volume and particles. Remember, guys, the particles stay the same. The mass stays the same. We are not changing the amount of particles that we have in the larger beaker to the ones in the smaller beaker. The particles are equal. Okay, so here in volume 1, which is this beaker here, the particles are moving around more and we have less collisions, and the pressure in this particular beaker is less as compared to this one, where the particles are colliding with each other more and there is an increase in pressure. So guys, an important thing to note is that an increase in collisions equals to an increase in pressure. All right, a decrease in collisions equals to a decrease in pressure. All right. Okay, so now guys, that brings us to the end of the particle model of matter. And I basically just got the summary straight from the Siyavula textbook, and I just like to go through with it with you guys. So these are basically the key concepts that you guys should know. Remember, today we are basically wrapping up with revision with regards to the particle model of matter, right? So the key concepts, remember, all matter can be described in terms of particles that it consists of. And then the theory describes matter in terms of particles is called the particle model of matter. And it helps us understand microscopic properties of material in terms of the behavior of the particles. Very much important to note that we are dealing with the particles. Okay, so the particle model describes particles of solid as follows. They are closely and regularly packed and locked into position. The only movement they are allowed is vibration, okay? And they are held together by strong attractive forces, and we have little spaces between the particles of a solid. Then when we move on to the liquids are also closely packed together, but they are not locked in position. They are in constant motion and they slide past each other, and they are held by moderately strong attractive forces. Okay, and the spaces between particles of liquids are very small. Okay. So remember, guys, if you do have any questions with regards to particle model of matter, now would be a great time to actually ask, because tomorrow we're just doing an informal assessment via Kahoot, and Monday we'll be starting with chemical reactions, all right? Or revising chemical reactions. Okay, so then let us look at the particle model of matter with regards to gases. We say that gases are in constant fast motion. they are arranged in a way that they are free to move, and then the forces between them are weak. So these are the attractive forces between gas particles. They are weak, and the particles are far apart with large empty spaces between them, right? And then since the particles of liquids and gases are in constant motion, they are able to diffuse. Okay, diffusion is the process in which particles spread out through random movement from high to a low concentration until we have equal distribution. All right. Okay, then when two substances mix, their particles intermingle until the composition is in uniform throughout. Okay, this is what we also call diffusion. Then changes of state are usually as a result of heating or cooling. Remember, we are either adding energy or we are losing energy. Or rather, our particles are either gaining energy or they are losing energy. So when a solid is heated, it will change to a liquid, and this process is called melting. And when heated further, the liquid will change into a gas. Okay. Then when a gas is cooled, it will change to a liquid, and this process is called condensation. And when cooled even further, the liquid will change to a solid by the process called freezing. Then the density of materials is a measure of its relative heaviness, okay? Denser materials have greater mass in relation to their size, and that is why they feel heavy. Okay, then the density of material depends on two things: the mass of the individual particles of the materials. So the larger the mass, the denser the material. Then the size of the spaces between particles of the material, where we have larger spaces means that we have less dense material. So these explain, remember guys, how we calculate density. It is equals to mass over volume. All right. Then materials with loose texture, like bread and sponge, for example, have empty spaces or holes inside them, which means that they have less mass in relation to their volume. These materials tend to be less dense. Okay, so remember guys, if we have different materials in a beaker, the less dense material will always settle on top. For example, if we have oil and water in the same glass, the oil will settle on top because it is less dense. All right. Let me see if we have any questions. No, guys, the lesson is not yet done. We're not done. All right, we're not done. Okay, and then particles of matter are constantly moving. In solids, these movements are limited to vibrations, but in liquids and gases, particles have more freedom. Okay, most materials will expand when they are heated and contract when they are cooled. All right. So guys, if we want to know how much of a gas we have, we can measure the pressure of the gas. Remember, the pressure of a gas is caused by the particles of the gas colliding with the inside of the container and with each other. Okay, so more gas particles inside a container will mean that we have more collisions against the sides and therefore more pressure. All right. And guys, we have basically here a concept map that is summarizing everything that we have dealt with. So guys, we can just start here at the particle model of matter and you guys can move with me. All right. So the particle model of matter explains all matter is made up of particles which are too small to see, and these particles basically refer to the atoms and molecules which are found in the substance, and there is spaces between the particles. All right. Okay, and these particles can be found in three states, which is our solid, our liquid, and our gases. All right, so remember that the three states are solid, liquid, and gases. They differ in density. Okay, density refers to the amount of mass per volume, and density also differs in terms of the material that is used. Okay, so our three states can also be changed by heating or cooling. So guys, I want to know from you, when we heat, right, a gas, liquid, or a solid, what does heating cause? What does heating cause the particles to do that would cause an increase in space? I need you guys to fill in the missing word here for me. It says that the three states can change in state by heating, which causes, I need you guys to fill this part in for me. You can just send through the answer to the group chat. Okay, Chesa says more pressure, and that means they change faces. Okay, just go back to yesterday's lesson, all right? A hint is yesterday's lesson. What were we dealing with in yesterday's lesson? Remember, when we heat a material, it is most likely to beautiful, guys. It is most likely to expand as spaces between them increase. All right. So what's missing here is that heating causes materials to expand as spaces increase between the particles. All right. So then when we cool the material, it causes it to contract as spaces decrease. All right, guys. Okay, so we can also just move on here. We say that solids, they are closely packed and do not move around but vibrate and have strong forces and also have small spaces. And then the liquids here, they are loosely arranged, move fast and slide past each other and have weaker forces and small spaces. Then the gas, they have no arrangement, move very fast, have very weak forces and have very big spaces. Both liquids and gases can diffuse. Right? They can diffuse as they move from highly concentrated area to a lower concentrated area. Right, so that brings us rather to the end of the section of particle model of matter. So guys, just remember to do your homework. And if you do have any questions, please do post them on the group chat. And we are basically at the end of our lesson. So guys, these are the textbooks that we used to compile the lesson. It was the Savula Grade 8 Natural Science textbooks and the Oxford Successful Natural Science Learners book from Snaplify, as well as the ACID study guide. So guys, remember, you can also get these textbooks for yourselves on Snaplify. Just download the app on your phones and you can download these textbooks. All right. So next lesson is a Kahoot. Please guys, just prepare for tomorrow. Study your work. Make sure that you understand everything. Tomorrow we'll be playing Kahoot. Okay, so thank you very much guys for attending. Remember, if you do have any questions or want the slides, do drop me an email on onkarabetse.setso@gmail.com. And remember to follow Africa Teen Geeks on all the social media platforms. So guys, have a great day further.